In our example 8, and I hope this is our last example on this concept, sequence, and series. We are given that the houses on the side of a particular street are assigned odd numbers, starting from 11. If the sum of the numbers is 551, how many houses are there? So if you look at this problem now, they said they are assigned odd numbers, meaning that if the first number is 11, this implies that if the first number we have for the house, for the first house is 11, that is A equals to 11. And since it is odd numbers, after 11 we have 13, after 13 we have 15. That means the common difference is 2. And another value we are giving here is that if the sum of the numbers, all the numbers, if you sum them together, since we don't know how many are there, so we say S subscript N is 551, meaning that we are looking for the value of N. That's what we don't know. We don't know how many houses are there. That's what we want to do. So in this case, we use the sum formula. We say Sn equals to N over 2 into 2A plus N minus 1D. From there, we substitute for Sn, which is 551, equals to N over 2 into 2A. Our A is 11. 2 times 11 plus N minus 1 times D. The common difference is 2. So we can open this. This will give us 551 equals to N into bracket 22 plus, if you open this smaller bracket, it is 2N minus 2. 2N minus 2. But this 2 here, it's like N is multiplying everything. This 2 will come down as denominator over 2. But mind you, in that case, it's signaling that we'll later cross multiply. So this will later come here. And if it does, we have 551 to multiply 2 equals to N. We open the brackets. Inside the brackets, we have 2N plus 20. 22 minus 2 is 20. That is 2N plus 20. From there, we open 551. 551 times 2 should give us 1,102, which is equals to, opening brackets here will give us 2n squared plus 20n. 2n squared plus 20n. So what have we observed this equation to be? It has become a quadratic equation. So we need to normalize it. How do we, what do I mean by that? Moving this constant to the right so that everything will be equal to 0. So in this case, we now have 0 equals to 2n squared plus 20n minus 1102. So in every equation, if there's something that you can use to reduce it, that is, if there's a particular number or letter that can divide through, so as to reduce the equation, is to our own benefit. But if you don't want to do so, we are good to go. We can solve this equation directly like this. But since 2 can go through, let us divide all through by 2. So 2 divided by 2n squared divided by 2 is n squared plus 20n divided by 2 is 10n minus 1102 to 1102 divided by 2 will give us 551. So equals to, if left equals to right, right equals to left. So equals to 0 divided by 2 is 0. We can now solve this equation. But because the constant here is a big number, so it is possible that this quadratic equation is factorizable. I don't want us to worry ourselves looking for two terms that we had to get this one, and when we multiply to get the constant here. So rather than doing that, I want to apply the quadratic formula that within a mathematical domain we call almighty formula. So we have the coefficient of n squared is a. A equals to 1. B is the coefficient of n, which is positive 10. And C is the constant we have here, which is negative 551. And we are using, the formula will now be made of letter n, since our quadratic is of letter n. So it will be n equals to negative b plus or minus square root of b squared minus 4ac, everything divided by 2a. So let's complete our working on this left side. So we want to substitute appropriately. We have n equals to negative b. B is 10, so it will be negative 10 plus or minus square root of b squared, that is 10 squared, minus 4 times a. 4ac is 4 times a is 4 times 1 times negative 551. Everything divided by 2 times a, which is 2 times 1. Then we have n equals to negative 10 plus or minus square root of 10 squared is 10 times 10, that is 100. So you have to be careful here. These three terms, they all multiply together. And if you look at their sign, negative times positive here is negative, and that resultant negative times this another negative is positive. So we have plus. We now have 4 times 1, 4. 4 times 551. 4 times 551. That should give us 2204. 2204 over 2 times 1 is 2. So we now have negative 10 plus or minus square root of, if you add 100 to 2204, that will give us 2304 over 2. And this implies negative 10 plus or minus, what's the square root of 2304? That gave us 48. So over 2. We can now say n equals to negative 10. This one means negative 10, negative 48 over 2, or n equals to negative 10 plus 48 over 2. The reason being the fact that we have plus or minus here. First take care of, you can first take care of the positive, or if you like, first take care of the negative like we did here. Negative 10, negative 48 over 2, that's this, or negative 10, positive 48. So that's what we have there. And that will further generate, so let me quickly write the meaning here. So that will give us n equals to negative 10 plus negative 48. That's negative 58 over 2, or n equals to negative 10 plus 48. That is 48 minus 10. That is positive 38 over 2. And finally, if you divide negative 58 divided by 2, first of all, negative divided by positive is negative, and 58 divided by 2 is 29. We have negative 29, or n equals to 38 divided by 2, that gives 19. So at this point, you must not say this is your final answer, because how many houses are there? So the number of houses that will be there cannot be negative. Hence, you conclude that, therefore, n equals to 19 houses. Since n cannot be equal to negative 29. So that is the value, the number that we have there. And this is the end of our sequence and series, as it particularly centers around arithmetic progression and geometric progression. If this is the first time you come across this channel, kindly subscribe and share the video to other students to benefit as well. We have mathematics videos for senior secondary, we have for junior secondary, and as well as those pupils in primary school. Okay, that is perfect. So the answers are given there. When you attempt